Section 9.2, Piecewise Functions. How do I graph piecewise functions? A piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of the domain. A step function is a piecewise function that is constant for each interval of its domain. Here's a reminder. When using interval notation, square brackets indicate an included endpoint and parentheses indicate an excluded endpoint. So on example 1, we're going to create a table and a verbal description to represent the graph. So we have the graph in front of us, and it's talking about mixed nuts. The weight is the x-axis and the price per pound is the y-axis. Because the endpoints of each segment of the graph identify the intervals of the domain, use the endpoints and points close to them as the domain values in the table. So let's create our table over here. We have our x and our y. And on our x value, we are going from 0 to 2. And at 2, there's an open circle. And the next interval here, we have 2 to 5. 5 is the open circle. And then we have 5 to infinity. So we're heading off forever. And we're assuming a closed circle there. So the brackets are where the closed circles are. And the parentheses are where the open circles are. And the y values that go with this interval of x values is 8. 2 to 5 is 6. And 5 to infinity is 5. So the verbal description is going to be mixed nuts cost $8 per pound for less than 2 pounds. That's what's happening here. And $6 per pound for 2 pounds or more, and less than 5 pounds. And the last part is $5 per pound for 5 or more pounds. So we're looking at the table, or looking at the graph, I should say, and writing a verbal description. Example 2, we're going to do in class. A piecewise function that is constant for each interval of its domain, such as the ticket price function, is called a step function. You can describe piecewise functions with a function rule. The rule for the movie ticket prices from example 1 on page 662, that means in the book, is shown. So let's go over it. It's basically saying that if someone is in between the ages of 0 and 13, but not including 13, they will pay $5 to enter the movie. And in between 13 and 55, but less than 55, they will pay $9. And anyone 55 or older will pay $6.50. To evaluate any piecewise function for a specific input, find the interval of the domain that contains that input, and then use the rule for that interval. So on example 3, evaluate each piecewise function when x is -1 and x is equal to 4. So when x is -1, well, when x is -1, I have to use this first one because that's where x is less than or equal to 2. So I go 2 times -1 plus 1 is -2 plus 1 is -1. That's the value of the function when x is equal to -1. When x is equal to 4, let's change colors here. I have to use this one because that's where x is greater than 2. So we have 4 squared minus 4. That's 16 minus 4, which is 12. Example 4. Evaluate each piecewise function. In this case, we're talking about x is -1. So we're going to use this one right here. So g of -1 is going to be 2 to the -1, which is going to be 1/2. And the other one is talking about evaluating the function when x is equal to 4. Well, that's going to have to be in this group because that's where x is greater than -1. So 5 times 4 is 20. Example 5. Evaluate each piecewise function. So when x is -1, so we're finding the value of the function when x is -1. Well, where does that fall? Well, -1 is not less than -3, but -1 is in between -3 and 6. So that answer is 15. Now let's change our color. When x is equal to 3, so f of 3, where does 3 fall? Well, 3 is not less than -3. Oh, but 3 is in between -3 and 6. So the value of the function is 15. So on piecewise functions, we're looking to see where the x values falls to know what function to use to find the value of the function at that particular x value. Example 6, we're going to do in class, and now we're on to example 7. You can graph a piecewise function by graphing each piece of the function. So here is the trick that I like to use. I'm going to use colors here. I'm going to graph each line. We have 2 lines going on. G of x, which we can call y, equals 1/4 x plus 3. And the red one is -2x plus 3. I graph the lines and then I graph them and then I decide what part I'm going to erase. So the y-intercept is 3 and the slope is 1/4. So up 1 over 4. 1, 2, 3, 4. Or down 1 to the left 4. 1, 2, 3, 4. And I draw my line. And then I look. We're dealing with x less than 0. Well, when x is equal to 0, it's right here. I go when x is 0 and I go up, x less than, that is an open circle right there. And x less than 0 includes everything to the left of that. That means I have to erase everything to the right of that. Now let's graph the red line. Y-intercept is 3 and the slope is -2. Down 2, 1, 1, 2, to the right 1, down 2, to the right 1, down 2, down 2, or up 2 to left 1. And now we're dealing with x is greater than or equal to 0. So I go to 0, I go up, x is greater than or equal to 0, then is that's a closed circle there. And the line we're going to deal with is everything this way, greater than or equal to 0. And that means that this is not included. And that is how we deal with a piecewise function. And I can show that the open circle was still there for the blue, but it was closed for the red. Eight and 9 we're going to do in class. And there's our video questions. Please pause the video and do them in your notes.